Algorithms question, we have been given an undirected graph having this edge weights as shown in this figure. We have to determine what would be the number of minimum spanning trees existing for this graph. Now, since we can see that all the edge weights are not distinct, so it will definitely have more than one spanning trees. But how many? For that, we can apply either Kruskal's or Prim's algorithm and determine what is the result we get. Let us go ahead with Kruskal's algorithm. We have these 9 nodes. Let us denote them here. Right, and there are only two different edge weights, as we can see. It is 0.1 and 0.9. So let us start with this vertex, and we will be following Kruskal's algo. So we'll keep adding the edges with minimum weight such that they do not create a cycle. So here we'll start by including this edge first, having the weight of 0.1. This edge is included, then we can go ahead with this one, 0.1. Now in this upper component, there is no other edge having the minimum weight of 0.1. So now we'll go for the lower component, and we can include either of either of these 4 edges. All of them are having weight 0.1. So we'll include all 4, seeing that they do not create a cycle, which they will not in this case. There are 5. This middle one is also there. So all of those 5 edges will be included in our MST. So we have reached till this point, and now there is no edge left having weight 0.1. So we only have these 3 edges left, which are having the weights 0.9 each. But as we can see, our MST is still having 2 different components, and they will need to be connected to each other. And we are having 9 vertices. So what is the number of edges we'll need to have? So 9 minus 1, which is 8. And how many we have already had? 7. 1, 2, 3, 4, 5, 6, and 7. So we just need one more edge that will connect these 2 components together. And how can we do that? We'll select, we are having 4 options, these 4. But if we add this edge, then it will create a cycle, so it won't be anyways included. So then out of these 3, we will include any one. We can have either this is an MST, or we could have in place of this the middle one. This is also an MST. Or instead of this, we could have had the last one. All of them are possible. No cycle would be created. The 2 components would be joined to each other, resulting into an MST. So we are having just 3 different options that we can choose any one of these 3 edges. For others, there is no option. All the edges having weight 0.1 will definitely be included. We just have an option among these 3. So there are 3 different MSTs possible for this graph. So answer would be 3.